Hey guys, we're Team No Logic Please, and we're here to present our NLP project. And first of all, we'll go over the overall structure of our application. So it's divided into two parts. One is question generation, and the other is question answering. And I think the structure will be, the workflow chart is pretty straightforward. And so we'll dive deep into the first part, the question generation. Yes, so for question generation, we need to extract information from the text first, and so the way we're implementing our relation extraction is through identify the root of sentence and also extracting the corresponding relations into the format of subject, verb, and object, and feed it backward to the question generation machine. And so we'll parse every sentence based upon the root, and also other than the root, we'll also pay more attention to other potential valid verbs and action in each subpart of the sentences. And also what's optional is the inclusion of context, such as time, place, conditions, and the graphical is sort of demonstrating how the dependency partitioning spacing works.
So there are two types of question being generated. The first type is like WH question. So first we get the relationship extracted from relationship extraction. So we get a bunch of subject, verb, object pair. And then the most common type of problem is to substitute subject or object by what, because those can most frequently be referred by what, like what dropped dramatically to 0 Celsius degree. And also then we do a name entity extraction. So there are 6 major class: person, location, date, event, GPE, and ORG, and they basically correspond to when, where, why, and what geographic location, and etc. And another thing that question generation do is tense correction. We identify the whether the thing is in past tense or present tense, and also it might be in third person present tense, and then we change our verb to fit with the grammar. Another type of question is binary question. So to create binary questions, we extract auxiliary verbs from the text, like is, are, was, were, and those are already correctly fit with the tense, like has, have, or must. Those auxiliary verbs can be probably placed at the beginning of the sentence to create binary question, like was the first parallel of the Old Kingdom destroyer, or must the people in Egypt fight the intruders? The last thing, after we get binary questions and WH type of question, we do a question augmentation by doing synonym substitution so that it becomes more complicated but still remain the meaning. For example, we can substitute collapse by fall, like who caused the fall of the Old Kingdom, and also we can substitute like succeeded by come after, who succeeded the Old King, into who come after the Old King.
All right, so next we'll move on to question answering. So I created a sentence ranker that evaluates the grammar and structure of both answers and questions. To make it simpler, I wrote a helper function that converts a question into a declarative sentence format. We check things such as grammar, so subject-verb agreement and plurality agreement. We check for the existence of important entities, a subject, verb, and object, and we also evaluate the sentence length and deduct points accordingly based on these characteristics. The sentence has a starting point value of 10 and can go all the way down to 0 based on these characteristics. So after evaluating the question, if we deem that it's good enough to answer, we check the sentences throughout the document, also assigning a score between 0 and 10 to see which one is most relevant for answering the question. So we look for characteristics such as word matching, so seeing how much certain vocabulary is used within that sentence, matching with the question. And then we also use word embeddings and cosine similarity to also further evaluate the candidate sentences.
So for who, what, which type of questions, they're typically asking for subjects or objects. We use 2 ways to generate our candidate answers. So first way is spacey part of speech matching. We just use the tags to match the subjects and the objects. And the second way is to use relation extractions, which we write in our own functions. And now we get 4 answer candidates. Now we ask ourselves whether the question is asking for the subjects or objects. We do this by using a simple method, checking whether the question containing the subjects or the objects Now we're shrinking down to 2 answer candidates, and we just evaluate which of the answer candidate is better. Now we get the final answer.
So next, we try to answer when-where questions. We look for named entities. So for where questions, we look for things like GPE, location, organization, and for when, we look for quantities such as date and time. And we try to locate the ideal prepositional phrase within the question that has the ideal named entity, and restructure it to create the answer.
Well, so for answering how-why questions, we place a heavy emphasis on prepositions and specific phrases such as through, by, because, due to, and then we'll extract the corresponding subtree dependencies. And also for some why questions, we are also trying to search for reasons in nearby sentences, like the one before and one after, since the sentence we matched could be explaining the result. And so we have binary questions left, and for those questions, we want to make comparisons between the question and sentence identified for having the answer. So we'll check if every word in the question exists in the sentence identified or is similar enough. And also we use the negation tag in spaCy taggers, dependency parsers, to deal with the double negation problems in binary questions. Also, that concludes our application, and also looking forward, we should probably do something more to deal with the entity coreference to remove the ambiguity in understanding of text and in relation extraction, and also writing more rules for different sentence structure will also help in generating question and also in relation extraction both. And also our application right now is not quite scalable for large-scale Q&A answering. So we should probably try alternatives like neural networks, and right now the transformer model is very popular, and based upon paper, attention is all you need. And yeah, so this will conclude our presentation, and thank you very much for watching.